check, 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 check. Yeah, check. So, good morning, students. Am I audible, visible? Participant. Participant is only one. Okay. So, okay. So, check, check. Yeah. So, yes, 10 of you are there. I hope it's same. Uh, uh, I'm clear as before. Yeah, I'm audible and visible as before. This is this will be the first session in this course, which I'll be taking via TCS platform. Of course, eventually it is Zoom only, but we had to log in via TCS. So, am I audible?
Yes, sir.
Okay, but you are not. Check, check, check. Yeah. So, the sound. Okay. Now you people should also be audible when you say something. Okay. So I'll share the screen. So yesterday we tackled different types of means. Yeah, we tackled different types of means. Yeah. So we discussed about harmonic mean and geometric mean. Arithmetic mean we already had discussed. Yesterday we discussed geometric mean and harmonic mean, when they are used and how to calculate them. Okay. So in geometric mean, remember, if there are more numbers, then you want to find the geometric mean of those numbers. You have to take the nth root. If there are three numbers, you have to take the cube root of their product. If there are four numbers, you have to take the fourth root of their products. Yeah, like that. Harmonic mean calculation actually is simpler than geometric mean. Yeah. If you want to calculate by hand, it will be simpler. Harmonic mean is simpler than geometric mean. Yeah. So we saw a situation in geometric mean. We saw this situation. If you remember, I'm just showing you the situation. I'm not solving the problem today again. I'm showing you the situation. So this was the situation in geometric mean where geometric mean is applicable. Okay. Yeah. So I'm not very sure whether you will be audible, so you can also put it in chat. If I am, if you see I'm not responding to some question, your doubt, then you can also write in chat, because yeah, there may
Okay,
be
sir.
some. Okay, okay. Actually, I'm able to hear. Okay, great. Yeah. So geometric mean was that. Harmonic mean is this situation, the second situation. Yeah, where the numerator is constant and we want to find the average. Okay. Here we want to find the average speed, and the numerator, that is the distance, is fixed. 1 lap, 1 lap. So what should be the average speed? In this situation, we use harmonic mean. Okay. So now going forward, we will have a look at some of the graphs. Next topic, today's topic is graphs actually. Yeah. So we will see not all the graphs, but some of the graphs. Basically, we'll see histograms, pie chart, and box plot. Box plot is more rich, more uh, things have to be discussed in box plot. So we will devote little more time to box plot than histogram and pie charts. Of course, we are using Excel, so a click of few buttons we can draw. But what is going on inside, अंदर क्या चल रहा है उस process में, histogram draw करने के process में, that we should know. So we will try to draw it by hand as much as possible. Of course, I'm not using a pen tab, otherwise I would have actually drawn with hand. Yeah. So now we want to draw a histogram. For histogram, what we want is the values of variables, any variable, say your height. Yeah. So all of your heights we are measuring, or all of your weight we are measuring, or the temperature in any place we are measuring. Like before the earlier example, while using mean, we used temperature. Yeah. Values, and here we will need frequency. Okay. So values here say height in centimeters. So suppose there are few people with 150 centimeter height. There are few people with 165 centimeter height. There are few people with say 170 centimeter height, and there are few people with 180 centimeters. Just for the sake of ease, we are not taking an intervals here. Ideally, you should take up to 150 centimeters, then 150 to 165 centimeters, then 165 to 170 centimeters, then 170 to 180 centimeters, and the last category we can have more than 180 centimeters. Okay. So like that also we should take, which will be more realistic, but this data as it is simpler. So we are beginning, so we are taking the simpler example than a more realistic example. Okay, beach में just a second. Sorry about that. Yeah. So frequency, see you're about less than about 20 people say. So you're there. So say suppose 10 people have this height. Yeah, 5 people have this height, and then again 10 people have this height, and 5 people have this height. So frequency also we have taken very simple numbers. Yeah. So now we want to draw a histogram for this data. So histogram is basically a bar graph. Okay. So on the y-axis, say this is the y-axis. So on the y-axis, the frequency. So we will take the frequency, and here we will take the variable, that is height. Yeah. So now draw the box. Which point should it start, which point should it end? So that looks very simple when Excel draws it automatically at the click of the button. But when you have to draw, when someone has to draw, you or me has to draw, we have to decide from where the bar will start, the line of the bar will start. So here it is 150. So we can have this point as 150, this point as 160. Yeah, we can write that. Will be a little difficult to write. So here, suppose this point, this junction is 150, 160, 170, 180, and 190. So for 150, the frequency will be 10. Yeah. So here we can write the frequency. Say frequency, because there are less values, less options, we can actually write 1, 2, 3, 4 frequency. Here the name of the axis, 6, 7, 8, 9, 10, and let us keep one more so that it looks good. Otherwise it will be very congested. So 9, 10, yeah, and 11. So for 150, the frequency is 5. So we have to draw a bar, simple bar for 150 against 150. Okay, which will end at 5. So from this is the portion from where should the bar start? That is the question. Now, yeah. So this bar which we will draw should start in the middle. Yeah, in the middle of this distance. So here at this point it is 150. So from the middle of this point to the middle of this, between 150 to 160, the midpoint of this distance. Okay. So it will start from here. It will go up till 150. We will draw a graph. We will draw a bar, and it will come down at the midpoint of 150 and 160. So similarly, we will draw the rest of the 4 bars. Okay. So you can try it out in your notebook. Yeah. You can try it out in your notebook. Just for the sake of it, let me also try a this thing. Okay, it has taken these two as axis. So we do not want to do that. By the time you can draw it in your notebook, so you can label this axis, height axis, 150, 160, 170, 180, 190. and these are the frequency, and you can draw those bars. Okay, so that this diagram will be called as histogram. And after that, we will do one more thing. There is one more thing to be done in histogram, which is drawing a curve. Which is drawing a curve. I don't know why it is taking both the graphs, both the variables as both the variables for plotting. So if we have a frequency like this, yeah, so it will show something like this. So in place of 1, 2, 3, 4, you can imagine 150, 160, 170, 180. Yeah, so Excel has a slightly different way of drawing this graph. So ideally the output should look like this. So in the middle it will be 150, and halfway through 150 you will start the bar. It will go up till the frequency, corresponding frequency. Yeah, and it will come down halfway in the middle between 150 to 160. So this is how a bar graph looks. I think I'll have to start using pen tab from the next class. Today I have not brought, but anyway, we'll of course we'll be able to manage. So one more thing you can draw in this histogram is, if you take the upper midpoint of each of the graphs, each of these bars, if you take the midpoint of this bar, midpoint of this bar, midpoint of this bar, midpoint of this bar, and join that with a freehand drawn curve. Yeah, एक हाथ से बनाया हुआ एक अगर कर्व इस पे आप फिट करते हो इनके मिड पॉइंट से, so that also shows a trend, that shows the trend in a clearer way, and that graph is called ogive. 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 Okay, so that is an important element of histogram, you can say. Yeah, so this is about histogram. And the same data, if you want to draw in the form of a pie. Yeah, you know how a pie looks like, a circle, and depending on the frequency, the pie is divided. So for the value which has frequency higher, more portion of the pie will be there. Yeah, suppose you draw a circle. Yeah, from the center we will start, say from the vertical line we will start, and we draw a pie or draw a pie chart, how we will distribute the entire area. Just think about it for a moment. You want to draw a pie chart, yeah, so which is like a circle, and the area of that circle we will distribute according to the frequency of its values. Yeah, if the frequency of some value is high, we will allot a bigger portion of the circle. If the frequency is low, we will allot a smaller portion of the circle. Yeah. So you can, all of you can draw a circle, of course. So the circle will have a center, and from the center you can draw a vertical line. Yeah. So that will be our beginning point, and yeah, then we have to decide how to distribute the area. Now the total frequency is 30, right? the total frequency is 30. Now we are talking about pie charts. If you want, I can copy it so that there is no confusion and remove this. Yeah. Okay. So now we can focus on just drawing the pie chart. So total frequency is 30. So the entire area of the circle should represent the frequency of 30. Yes. So 30 then means 360 degree. You're drawing a circle and the entire frequency, which consists of 30, should cover the entire circle. Yeah, the total of the frequencies should cover the entire circle. Now, if the frequency is 10, how much degrees should be that portion, that seemingly conical portion? Are you able to follow what I'm trying to say? Or we need to find out something else, some other means to represent this? Yeah. So here you can see 1 corresponds to this category 150, which is almost twice in area compared to, yeah. So this is 150, which constitutes 23% of the area. This is 165.
Yeah, and the syllabus which you have sent it to me on that day, shall I share that soft copy with me now also, so that the same will be followed for us?
Okay, obviously this is not giving a correct picture because the frequency of 10 should show.
Sir, हमारा audit नहीं हुआ है. We are not hopeless. You just any time can ask.
Yeah. So okay. So it will not take this value. So I'll have to figure out a different way to draw this graphs. I'm sure there is a way. I'll use it multiple times, but it has just slipped off my memory as of now. Yeah. So this category 1, that corresponds to 150, height 150. The frequency is 10. So this much area will be allotted to 150. Then for 165, almost half of that area. If you consider it as 2x, this area will be x. And then again it is 10. So this would be again 2x. And for 180, this should be 5. So what will happen if we change these values? Say we make it, instead of 20, suppose we make it 15. And we make some value as 0, or say very less 2. Yeah. So like this, the portion of the circle allotted to that value will change depending on the frequency. You can play around with it. You can change anything. You can change these things a lot. See, you can make this 120. So see how it changes, how the graph changes. Yeah, see, now this is the biggest portion, 165, because the frequency is highest, the highest portion is allotted, and exactly if you calculate, it will be 43% of the area. When you're drawing by hand, what we do is we calculate the total frequency, and that total frequency constitutes 360 degrees. Yeah. A circle will have 360 degrees if you go around the center. So this entire measure will be 360 degrees. So depending on what is the frequency, we will allot that many degrees to that particular value. So 47 here in this case, say 47, or let's make it a, yeah, 50. 50 here corresponds to 360 degrees. Yeah. Frequency 50 units correspond to 360 degrees. Now 1 will correspond to how much? 1 will correspond to how much? 360 divided by 50. That is 7.2 degrees. Now we can take the frequencies individually. 15 will be how much then? 15 will be how much? 1 is 7.2 degrees. So 15 will be 15 multiplied by 7.2. If you want, I can write, or we can do cell referencing. Cell referencing is just going to that place and clicking on the value you want to refer. That is called cell referencing. Cell referencing in Excel. So most of you might be doing it already. Others learned today. No problem. So everybody knows now. So 20 multiplied by 7.2. Yeah. So we are trying to distribute the 360 degrees into number of degrees corresponding to each of the value depending on their frequency. Depending on their frequency. Okay. So here it will be 10 multiplied by 7.2. One benefit of using cell referencing is if you change any value, you do not have to go everywhere and change that value. Change that wherever that value is used. Yeah. So I'll tell you what I mean. Yeah. So here I am not using cell referencing, I'm typing the value. So now if say I change any frequency, say 15, just 10, I make 15. So this changed 55, but this has not changed because I have manually typed. If I had used, yeah, cell referencing, then this would automatically change 55. Now I have used cell referencing. I have clicked here and clicked at the value I want to refer to. Okay, so now 55 corresponds to 360 degrees. Yeah, so now then 1 will correspond to, here also I can use cell referencing 6.5. Earlier it was 7 point something degrees, 7.2 degrees. Now it has, now each unit of the frequency corresponds to 6.5 degrees. Yeah. Now here nothing has changed. Why? Because I have manually typed it. I have not used cell referencing. If I use cell referencing, so 1 corresponds to 6.5 degrees, 15 will correspond to 15 multiplied by 6.5 degrees. Similarly, actually, the other value also we can refer. Yeah, 15, here I can refer this cell. And in Excel, as we are using Excel, if I fix this value, you need not worry about this part. So if you put a dollar sign, that fixes that reference. So every time it will take 6.5. It's okay if that fixing part you didn't understand, that is all right. Yeah. So if we sum all of this, you should get 360 degrees, or there could be a 1 degree error because we are not using all the decimal places. Yeah, okay, exactly 360 degrees. Okay, this is how a pie chart is drawn. This is the mechanism behind drawing a pie chart. How do we distribute the area of the circle into slices of pies? Pie is a dish. Yeah, you would have seen, you would have heard of some movie name which became very famous. Not a very good movie, but yeah, became famous somehow. So a pie and histogram, everybody understood what is going on there. Yeah, what is going on behind drawing those graphs. Are we still connected? Check, check, check. Yeah, seems so. हिस्टोग्राम और पाई चार्ट सबको समझ में आया?
Yes, sir.
Yes,
Okay.
sir.
Shubham, Shreya say yes. Okay. Okay. Very nice. Good. Yeah.
Sir,
So yes.
excuse
Yes.
me. Can you please explain the degrees in pie chart you made, like the technique? I didn't understand that.
Okay. Okay. Yeah. Sure. So the frequencies we have for each value, we have the corresponding frequency. Okay. Now we total the frequency. Our target is to distribute this circle into areas corresponding to frequencies. Okay. So now total frequency is 55. So this total circle now should we should be able to divide this total circle into 55 equal slices. 55 equal slices. Then each degree, each element, each unit, 50 each unit of those 55 slices will correspond here. If we take from the center, if we take that degree will be equivalent to 6.5 degrees. So if we divide this entire circle into equal parts based on the total number of frequencies, each part will be from the center. It will have this angle as 6.5. So 6.5, 6.5, 6.5, 6.5, like this. We will have 55 slices. Okay. Now that those slices we have to combine depending on the frequency. So here 150 has 15 of those units. Okay. So 1 unit corresponds to 6.5 degrees. Then 15 units will correspond to 15 into 6.5 degrees. So that is how you decide what should be the angle here. Here in this case, this is the blue angle. So what should be the angle here? It should be 98.2. 98.2 degrees. Okay. To draw by hand, of course, you will need a protractor. Yeah, protractor जो होता है. So you would have used it in classroom. Formulas नहीं समझ. Formula to as such हमने use नहीं किया. I think you mean this one only. How to calculate the degrees. So total frequency will be 360 degrees. पूरे सर्कल में एक पॉइंट से शुरू करके उसी पॉइंट पे आने के लिए to go 360 degree. I hope that is clear. From one point in the circle to come back to the same point, going parallel to the circumference, we will travel 360 degrees. Yeah. 360 degrees, 90 degrees. 90 degrees, you know how 90 degrees would be. Let's say right angle is 90 degrees. Yeah. Similarly, a circle, if we say, corresponds to 4 right angles. Yeah. One right angle here, one right angle here, one right angle here, and one right angle here. So the total is 360 degrees, yeah, for the entire circle. So those 360 degrees are divided into 55 parts. Are to be divided into 55 parts in this case because the total frequency is 55. Okay. Then each part will correspond to 6.5 degrees. Yeah. When we take a reference line, yeah, from the center, this vertical line we are taking as reference. From there, we are drawing for this 150, we are drawing 98 degrees. Yeah. So this portion represents 150. Then from there, from the end of this portion, we are drawing 130 degrees. Yeah. So like this brown portion then corresponds to 165. Yeah. And similarly, the other values, 175 is represented by this green portion, and 180 is represented by this violet, yeah, violet portion. Okay. So this is how a pie chart is formed. Basically, yes, as you pointed out, dividing the circle into number of degrees for 1 unit of the frequency, how many degrees we have to allot, that is the calculation. That is the calculation. Yeah, I think that is what Pradeep is also pointing to, and that is all. That is what Shreya also asked. Yeah. So this was histogram and pie chart. Okay. So these were the more simple graphs. You will be using them very frequently when you are making any reports. Yeah. So yes, you can do a lot of tricks in terms of how to have these numbers, how to have the percentages expressed inside the circle itself. Yeah. So you can play around a little bit in Excel when you're drawing it in Excel. When you're drawing by hand, this much is enough. Otherwise, you can. Yeah. So small tricks. There are actually hundreds of tricks in Excel. So the basic to draw a pie chart is this. You can learn a lot many tricks to make the diagram more appealing, more attractive, and more clear also. If everything is written here, yeah, the title also you can change different ways of making it more attractive. Yes. So I think some Excel course, or Tally course is also being offered to all of you. So there you can try out more options, maybe a dozen options. Here we are trying out only 1 or 2 options to learn the basics, to actually apply statistics concepts, uh, which is required. The minimum 1 or 2 options only we are trying out. Okay, so now coming to box plot. So for box plot, we need to understand a few things first. So suppose we are again given a data, say given a data of uh, number of what do we say? What should we say? Number of trees in your garden. Suppose all of you have gardens. So number of trees in your gardens. Okay. So one of you have 10 trees, one of you have 20 trees, one of you have 35 trees, one of you have 45 trees, like that. Yeah. So I, okay. So this is number of trees. Okay. Now, to draw a box plot, first we have to understand what is a quartile. 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 So to find out quartiles, we divide this entire data set into four equal parts. To the extent possible, we divide this entire data set into four equal parts. So how to do that? Of course, there is a very complicated mathematical way to do that, but there is a much simpler logical way to do that. See, first we divide the data into two halves. Let us see how many data points are there. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So we cannot choose a single number to divide into two halves. So we will choose the middle two values and take the average of that. So average of 45 and 50 will be, what will be the average? I'll write it here, 47.5. Okay. Now this 47.5, which is between 45 and 50, is dividing this entire data set into two halves. Now these two halves are done. Now the first half we will again divide into two halves. Yeah, again there is no middle value, so we will consider these two values and take their average, 20 and 35. What is the average of 20 and 35? You can actually calculate. 27.5. Now 27.5 is dividing the first half into two equal parts. In one part it is 10 and 20, in other part it is 35 and 45. Okay. Similarly, the bottom half, this one, we will divide into two equal parts. Again, there is no middle value, so we will take the average of these two, 55 and 70. 55 and 70, yes. So 62.5. Now these numbers are called quartiles. 27.5 is the first quartile. 47.5 is the second quartile. And 62.5 is the third quartile. Okay. Yeah. So quartile, if you know how to find out, if you have understood, then the rest is simple. Yeah. Do you want me to tell you if there were odd number of values? Here we had even number of values. We had 8 values. So every time we took the average of the middle two. If suppose there are odd number of values, it makes our tasks a little simple. I will also tell that very briefly. Yeah. Suppose there is one more value, 85. Now there are 9 values, so immediately we can find the middle value, the fifth value. Yeah. So fifth value will divide the entire data set into two equal parts. Then these first part and second part we will divide into again two equal parts. So the first part, if we want to divide into two equal parts, there are 4 numbers in this. Again we will take the average of this. Yeah, we'll take the average of that. So that will again be 27.5. You can calculate. Here also we have taken the average of these two same numbers. Now here again we will take the average of these two numbers, 70 and 80, which will be 75. So here in this case, this will be the first quartile, 50 will be the second quartile, and 75 will be the third quartile. Yeah. So either way, whether it is odd number of values like here, 9 values, or even number of values, you can find out the quartiles very easily in this logical way, in this logical method. Yeah. First divide into two parts, then the first part you further divide into two parts. The second bottom part you divide into two parts. It's that simple. So these are the quartiles which we will plot. Either you can plot vertically or you can plot horizontally. Either way. Okay. So if you want to plot, say, horizontally, now this I will remove to avoid any confusion or overlap. So we are focusing on. Yeah, we are focusing on this data set, and correspondingly, we have found out the first quartile 27.5, second quartile 47.5, and third quartile 62.5. Okay. Now, this is called box plot. Box plot. We are discussing box plot. Right? Box plot. Box plot is also called box and whiskers plot. So what are whiskers? We will see in just 1 minute. The next 1 minute maybe. Yeah. So box plot. Now we want to draw a box plot of this. So what we do is we have this axis. Yeah, we are drawing a horizontal box plot. So yeah. So we will have the x-axis, the values, these values on the x-axis, and 27.5. Say we are starting with 0 here. Yeah, at this end. Yeah, 0 till 80. So say 20 का अगर हम करते हैं 20, 40, 60, 80. So suppose, yeah, so this looks better. Okay, so on this axis we have plotted the values, and we want to first draw the first quartile. So that is 27.5. So wherever it comes, so this will be 30 will be in the middle. So 27.5 will be just somewhere here. So we will draw a line here. We'll draw a line here that will correspond to the first quartile. Okay. Then similarly, second quartile and third quartile we will draw. So first quartile at 27.5. Then the second quartile as 47.5 here, and the third quartile just above 60, 62.5. So this box which we will draw, that is called the box plot. That is the box we are trying to make. Let me see. There is a box plot. There is no box plot here, but I must show you some box plot. Otherwise, it would be. Let me see. I was trying out. If it is there. Yeah. So box plot, how it looks. Just we will learn these. Okay, so first we have to find the tree. This is what our environment looks like. Um, okay, oh, it should be there only. Just a second. Ah, okay, okay. Yeah. Now it should look. Yeah. And it should also work. Then there is a command box plot. Of course, very self-explanatory. So if I do this, yeah. So for a data given in that file, which we first read, yeah. So here is how a box plot looks like. This is a vertical box plot, of course. Yeah, you can draw a horizontal box plot also. So this lower one is the first quartile. First quartile. This middle one, darker one, is the second quartile, and this upper end of the box is the third quartile. Okay. Now you will ask how to draw these endpoints. How to draw these endpoints? These are called whiskers. Whiskers. Yeah. The endpoints are called whiskers. whiskers जैसे मूछें होती है चूहे या बिल्ली की मूछें होती है सो इस बॉक्स की भी मूछें हैं हाँ मूछे जैसा है so we call them whiskers so how to decide the endpoints of this whiskers is a little tricky so how do we do that is the lower endpoint we calculated of the whisker yeah so for that how do we calculate that is uh, first quartile let me call it I1 this I2 and third quartile is I3 okay so lower end of the whisker what we do is I1 minus 1.5 multiplied by I3 minus I1. Actually, this I3 minus I1, I3 minus I1 has a special name that is called interquartile range or IQR. IQR is I3 minus I1. Interquartile range. Yeah, you will remember. Yeah. I hope you are paying attention. Everybody is paying attention. Box plot is a wonderful thing. It tells many things. Yeah, some we can uh, again discuss it. I mean, we can discuss it further also little bit in the next session. As of now, we are discussing the initial things, yeah, which enables you to at least draw a box plot first. Yeah. Then we will see what are apparent how to analyze the box plot, what things come out of the box plot. Yeah. Okay, so this is the lower end and upper end of the whisker. As you can guess, it will be something corresponding. इसी के जैसा कुछ formula होगा. Yeah, so that is I3. This I3, third quartile, plus again 1.5, the same. 1.5 multiplied by I3 minus I1. That is 1.5. Yes.
Where did that 1.5 come from?
1.5 is a fixed factor we take. Yeah. So 1.5 is not calculated. It is a convention we are taking 1.5. It is fixed. Okay. Yeah. So these two will give us the endpoints. The endpoints you see, this lower endpoint and upper endpoint are calculated like that. Lower endpoint is this first quartile minus 1.5 into interquartile range. Interquartile range is actually this distance, right? The third quartile, yeah, here the third quartile value minus the first quartile value. Yeah, actually this distance is the interquartile range. Yeah. By seeing the box plot, you can immediately find out the interquartile range. Now, till this point, you understood what is box plot? Everybody understood what is box plot? Yes. Okay. Very nice. Okay. So now I have a question. I'll leave with this question, all 13 of you, that this I2, this second quartile, do you see anything special regarding this? Can we say this is either mean, median, or mode? Yeah, I have also given you a hint. Yeah, this I2 second quartile. If I am saying that it is one of these, mean, median, or mode of this data, what is this second quartile? Is it a mean? Okay, is it a mean, is it a median, or is it a mode? So one of you is saying median. So everybody agrees. Shall we conduct a poll? I think there is a option, breakout rooms. अच्छा नहीं वो भी देखना पड़ेगा ना. Yeah. So okay, yes. We need not conduct a poll then. So everybody is saying median, or anybody has a different answer? Somebody has typed also. No, okay. Any other answer? No other answer. Have you? Okay. Okay. Yes, median is the correct answer. I think you're in a hurry to. Okay. Yeah. So we'll meet again. As always, please send the attendance to Ashwini Madam. I have just noted down that 14 of you were there. All right.
Yes, sir.
Okay. Thank you very much.
Thank you,
See you
sir.
in the next session. Thank you. Thank you. Bye bye. Bye bye.